Hello, everybody. Hey, this is going to be a video on the answers to the linear momentum quiz practice. Okay, so number one is calculate the momentum of a 20 kilogram block that is sliding at 2 meters per second. Obviously, very simple. We just have mass times velocity, which is going to be 20 kilograms times 2 meters per second is going to give us 40 kilogram meters per second. And that, or those are the units for there, although we could have other units as we will talk about in a second. Okay, so number two, also if we look at the significant digits, that would have been rounded to 2. All right, so calculate the impulse of a 50 Newton force acting for 0.75 seconds. So remember, impulse is equal to force times time, so that's going to be 50 newtons operating for 0.57 seconds, which is going to give us 37.5 Newton meters. And I rounded that up to 2 significant digits, which would give us 38 Newton seconds, not Newton meters. Okay. Two ice skaters with an initial velocity of 0 are facing each other, and the first skater is 80 kilograms and the second is 60, and they push away from each other. The first skater travels at a speed of 4.2 meters per second. Calculate the speed of the second. So this is obviously based on the conservation of momentum. So we're going to have M1 V1 initial plus M2 V2 initial is equal to M1 V1 final plus M2 V2 final. So this is kind of always for two objects going to be our conservation of linear momentum. And obviously, if they are starting out facing each other and not moving, that is going to be going to 0. I'm going to pause here for a second and get that glare out of the way. All right, so we're back. And so what we're going to do is we're going to take this negative M1 V1 final is equal to positive M2 V2 final. And so we can kind of pick whichever one that we want. So the first skater is 80 kilograms, and the velocity is 4.2, and that's going to equal to 60 V2 final. 60 V2 final. So we're going to divide both sides by 60, and we're going to get V2 final. Is going to be equal to 80 divided by 60 times 4.2. We're going to get 5.6 meters per second. So that is 5.6 meters per second is the final velocity of the second skater. Now, because I said in the question that the first skater was 4.2 positive, then this answer has to be negative, because in order for them to add up to 0, one's got to be positive and one's got to be negative. So although I'm not writing it, we got to remember that these things are going to be vectors, and so they're going to have a direction. All right, number 4. We're going to take the scenario from number 3, the two skaters, and if they push off for 0.6 seconds, determine the impulse and the average force. So the impulse is going to be, okay, and we're going to do number 4 here. Impulse is equal to force times time, and it's also equal to the change in momentum, which is mass times the change in velocity. So we can calculate this change in momentum. So we are going to see 80 times 4.2, and because we started out at 0, and 80 times 4.2 is going to be 336. So our impulse is 336, and that would be Newton seconds. But we also notice here that those units could also be kilogram meters per second. So kilogram meters per second would be the same units as a Newton second. So typically, when you talk about impulse, you're going to use Newton seconds. And when you talk about momentum, you're talking about kilogram meters per second. But they're the same thing, and they would both be correct. All right. And so now, since we have the impulse, we can calculate the average force. So the average force times time is equal to the impulse. So we're going to divide both sides by time, and we're going to have 336 divided by 0.6. And we're going to get 560. So 560 newtons is going to be our average force. All right, ladies and gentlemen, that is the first 4 questions here. And I am going to move on here to question 5 through 7. Now, question 5 through 7 is dealing with this force versus time graph, and what we have here up here at the top, we're going to have 6 newtons, and we're going to have 0 seconds and 0.3 seconds. And it says, determine the overall impulse. So the impulse is going to be that area. So remember, if we had something like an unknown sort of function, that impulse would equal to the integral of force times dt, okay? But essentially, remember, an integral is just the area under the curve. And so we have an area here just because it's a triangle. So that area is obviously going to be 1/2 base times height, which is our base is 0.3 seconds and our height is 6 meters. And so we're going to get 0.90 Newton seconds, and that is going to be our impulse. All right, now you guys, as far as significant digits go, when you're looking at that graph, it looks like you only have one significant digit, but if you look at there, you can estimate a second significant digit in there, and therefore you should really have 2 significant digits in your answer. Okay, so that was question number 5. Now the average force, okay, we can see that maximum force is 6, and really we're going to end up here somewhere down here where we're going to get a rectangular area up here, which is going to be the average force times time, which is going to equal the overall impulse, okay? And so we're going to divide by time. So our average force is going to equal to 0.9 divided by 0.3. And that should give us 30 newtons, or 3 newtons. 3.0 newtons would be equal to our average force. All right, and number 7, if a racquetball with an initial speed of negative 1.2 meters per second is going to experience, that impulse, that force times time, then what is the final velocity? So now we're going to take this impulse. This is number 7. This is number 6. Okay, so impulse is equal to the change in momentum, which would be mass times v final minus v initial. So we know that this impulse is 0.9. So 0.9 is equal to, and we need to know what our mass of our racquetball, which is 40 grams. Okay. Now, if I did not give you guys that, then you just leave it in as a variable. Okay, so your answer could be something with an m in it. All right, so we're going to have 0.9 is equal to 0.04. Remember, you're moving it over 3 decimal points, and then that is V final minus the initial, okay, which is going to be negative 1.2. And so we're going to have 0.9 divided by 0.04, this whole quantity. This becomes plus, and so when we bring it over to the other side of the equation, it turns back to minus. We get 1.2, and that is going to be our V final. So we're going to go 0.9 divided by 0.04, which gives us 22.5 minus 1.2, which gives us 21.3. So our V final is equal to 21.3 meters per second. And that should really probably be 2 significant digits, not 3. But again, if you're within 1, you're gonna be good. All right, so that is 5 through 7. All right, so I'm going to pause here and erase everything, and we're going to move on to the next set of questions. All right, ladies and gentlemen, we are back to it, and number 8. You guys, number 8 is very similar to number 7. If we have a 25 Newton seconds is posed on a 12.5 kilogram initially at rest, then what is its final velocity? So again, we're going to have impulse is equal to the change in momentum, which is mass times the change in velocity, which is V final minus V initial. Well, our initial velocity is 0. Therefore, impulse divided by mass is going to give us our V final. So we're going to have 25 divided by 12.5, and that's going to be 2 meters per second. All right, so in question number 9, we're going to have this diagram here where we're going to have a ball come in, and it is going to reflect, and this is going to be an angle of 60 degrees and 60 degrees. And it is traveling at 12 meters per second. Now we're looking down on this from the top, so we're not going to get gravity that would pulls it down as if we were to see it on the side here. All right, so this ball has a mass that is equal to 100 grams, which would be 0.1 kilograms. So we want to determine the final speed. Now it says that it's perfectly elastic collision, right? So if we're starting off at 12 meters per second, then we're going to end at 12 meters per second. Now, notice that it did change direction. So that doesn't mean it's the final, that the velocity didn't change, but this was only asking what our speed was. Okay, so now calculate the change in momentum. And what we need to do is we need to look at, in fact, how that did change. And so we're going to draw vectors here in 2 dimensions. So we're going to have this vector, which is going to be 12 sine 60. 12 sine 60, 12 times is going to be 10.4. Okay. So we're going to have 10.4 going this way, and we're going to have 6 meters per second this way, which is going to be 12 cosine 60. And up here, again, our hypotenuse is 12, so we're going to have 6 meters per second, which is going to be 12 cosine 60. And again, we're going to get the same number of 10.4 going that way. But the key thing here is to notice that they are going in opposite directions. So it starts out at 10.4 and it goes, let's say, negative 10.4. So our change in velocity is going to be 20.8. 20.8. Now, we could call that negative or we could call that positive depending on how we started. But that is when we want to talk about the change in momentum, okay, we're going to have to add mass, which is 0.1, and then that would round down to 2.1 kilogram meters per second. Okay, and that is the change in momentum. All right, if the ball is in contact with the wall for 0.05 seconds, then what would be the average force? So remember, change in momentum is equal to impulse, which is force times time. So average force is going to equal to the change in momentum divided by time, which is going to be 2.1 divided by 0.05 seconds, kilogram meters per second. And let's get this 2.1 divided by 0.05, and that's going to be 42. So our average force is 42 newtons. Okay. So that was questions 9, 10, and 11. 9, 10, and 11, wherever they are down there. All right, so basically we are on to questions 12 and 13. So 12 and 13, okay. So what are the characteristics of an inelastic collision? From a very simple point of view, it's going to be hit and stick. And for an elastic collisions, it's going to be hit and bounce. Okay. But this one, momentum is conserved. Okay. And kinetic energy is not conserved. Okay. And so for our this top one is inelastic, and this one is elastic. All right. So momentum is also conserved. Okay. So momentum is always conserved. Okay. But if this is perfectly elastic, then kinetic energy is also conserved. And that's really all I'm looking for in questions 12 and 13. Okay, so let me erase this and we'll get up to the second question. Okay, for our next 4 questions, we have an inelastic collision. And in an inelastic collision, we're going to have M1v1 plus M2v2 initial is equal to M1v1 final plus M2v2 final. But because they hit and stick, we can combine the two masses together, and their final velocity, if they're stuck together, is obviously the same. So this makes it a very simple. It makes it a very simple calculation. But what is even more simple, okay, if the two masses are the same, and we can see here that in questions 14, 15, and 16, the masses are the same. And when the masses are the same, so if we notice here, this would be like 1m, 1m, and now 2m. So the m's would all cancel out, and we would end up here with a 2. So if we're looking for our final velocity, we're just going to divide by 2. And that is really just the average of our first 2 initial velocities. So that's what all we're looking for in 14, 15, and 16. Okay, so and we look at number 14, the initial velocity of the first ball is 5, and the second one is initially at rest. The average between 5 and 0 is going to be 2.5 meters per second. In question number 15, the first ball is moving to the right at 5, and the second ball is moving to the right at 2. So we're going to say 5 plus 2 is 7 divided by 2 is going to be 3.5 meters per second. Question number 16, we've got the first ball going at 5 meters per second to the right. The second one is going 5 meters per second to the left. That's negative. 5 minus 5 is 0. Divided by 2 is 0. So they're basically going to hit, and they're just going to stop right there. Boom, and they stop together. Okay, so it's really only question 17 that really requires much of a calculation here. And if we look at the first ball, okay, and I'm going to take it back to our initial equations here. Okay, so we're going to have our first ball is going to be 2 kilograms times a velocity of 5 meters per second. And that's going to be plus a 4 kilogram times a velocity of negative 5, because it's going to the left. And that is going to equal to 2 plus 4 is going to be 6 kilograms times V final. Okay, so we're going to have positive 10 minus 20 divided by 6 is going to be our V final. So obviously we're going to get negative 10 divided by 6. And negative 10 divided by 6 is negative 1.67. Negative 1.67, rounding to 2 significant digits, is negative 1.7 meters per second is our V final. Okay, easy peasy. All right, next section is on elastic collisions. I'll be right back. All right, so now we are going to do essentially the same questions, except now we're going to do it with an elastic collisions, which means they're going to hit and they're going to bounce off each other. And we're talking about a perfectly elastic collision, so both momentum, which is always conserved, and kinetic energy is conserved. What you may remember is we can end up with these two equations for calculating the final velocity. Now, this is a little more complicated, these equations, because the masses don't combine, and so we have an additional unknown. But regardless, you're going to use these equations. And like the trick that we had with inelastic collisions, where you take the average of the two velocities as your final velocity, if the masses are the same, we are going to have something similar with an elastic collision. And essentially what happens in a perfectly elastic collisions between two balls, the velocities are going to just change places. The velocities are just going to change places. So if we read question number 18, ball number 1 has 2 kilograms, moves to the right at 2 meters per second. Ball 2 has the same mass, but is at rest. Okay, so that means the V1 final, okay, is going to take on the V2 initial, which was 0, okay, and V2 final is going to take on the initial velocity of the first one, which is 5 meters per second. Okay, easy peasy, and it works for 15 and 16, and then it will get a little more complicated in question number 17. Okay, so the same thing. First ball going 5 meters per second, the second ball going 2 meters per second. So V1 final is going to be going 2 meters per second, and V2 final is going to be going 5 meters per second. Question number 20, we're going to have the first ball is going, starting out at 5 meters per second, and the second ball is going negative 5. So that means the first ball is negative 5, and the second ball is going to be positive 5. They are going to hit and bounce with the same velocities and go in the opposite direction. But what if, as in this final question of this section on 21, we no longer have the same mass, and now you guys now we're going to have to put that in this one. So I'm just going to superimpose our values right on top of our equations here. So the first ball is going to be 2 kilograms, and the second ball is going to be 4 kilograms. 2 plus 4 is 6, and our initial velocity of the first ball is 5 meters per second. 5 meters per second. And then our 2 times 2 is going to be 4 divided by 4. 2 plus 4 is 6. And our initial velocity of our second ball is going to be 5 meters per second to the left, which is going to be -5. Okay, so we're basically going to have, and we'll take this kind of down here. So we're going to have -5/3. Okay, so -2 divided by 6 is -1/3 times 5 is -5/3. And we're going to have 2/3 of -5. So we're going to have 10/3. Okay, 2/3 of 5 is going to be 10/3. But again, with the sign, that's going to be negative. So we're going to have -15/3. -15/3 is going to give us -5 meters per second. Where did I mess up here? Hold on, let me fix this because that's not coming out. All right, you guys, I made a simple mistake here. You guys, this one up here was 2m2, and the mass of the second object was 4. So this is actually 8. And so now this is going to be 8/3 times 5. So minus 8/3 times 5. And we're going to have, let me see, 5 divided by 3. 5 divided by 3 plus 40 divided by 3 is, all right, let me fix this because something is amiss. All right, I found it. So this is -8/6. So we're going to end up with -5/3 times -46, which is going to end up with -8.33 meters per second is equal to our V1 final. All right, let's see if I can do the second one here. So our V2 final is going to be 2 times our second mass, which is going to be 8 divided by 6 times 5. Okay, and now we're going to have 4 minus 2 over 6 times -5. And 40 divided by 6 is going to be 6.67. And then we're going to have 1/3 of 5, which is going to be minus 1.67. And that is going to give us 5 meters per second. Is that right? No. All right. Sorry, guys, I'm having a hard time. All right, again, I found my mistake. This is not 2m2, it's 2m1. So this is going to be 4. So we're going to have 2/3 of 5. 2/3 of 5 is going to be 3.33. This is still minus 1.67, which gives us positive 1.67 meters per second. And I think I rounded that up to 1.7. Okay, so again, when you guys see this question during the quiz, just take your time and be careful. make sure you have the right formula. Unfortunately, I remembered it slightly incorrectly, and that led to some confusion. Luckily, I worked it out before, so I knew what the right answers were, which are on your paper. All right, so I'm gonna be right back, and we'll do the last set of questions. All right, and welcome to the last set of questions, which is 22 through 25. So we have here an example of a ballistic pendulum that we went over. Now, I think the equations or the problems that we did in class and in your problem sets, I started out with giving you the height, and then you worked backwards to get to the initial velocity. And in this question, we're going in reverse. So what we have here is a 15 gram bullet with an initial velocity of 350. All right, so we're going to have 0.015 times 350 M1V1 initial plus our mass of our block is going to be 1.5, but it doesn't matter because our initial velocity is 0, so that's going to go away. And now we're going to add those two masses together, which is going to be 1.515 kilograms, and we're looking for our final velocity. Now, in question number 22, it's really just asking for our initial linear momentum, which is going to be just the mass times velocity of the bullet, 0.015 times 350. And that's going to give us 5.25. So 5.25 kilogram meters per second is going to be our initial momentum. Determine the velocity of the bullet and the block afterwards. And so when we do that, really to isolate this, we just have to divide this by 1.515 divided by 1.515, and our final velocity is going to be 3.47 meters per second. Okay, so this is question number 23. Question number 24. What will the maximum height be reached by? Again, so when we have these ballistic pendulums, we have the momentum side, and then we have the mechanical energy side, okay? So in this case, we're going to have 1/2 mv squared, the kinetic energy initial, plus the mgh, the potential energy initial, and that's going to equal to 1/2 mv final squared plus mgh final. Okay, now we can see it starts out, and if we make our h equals 0 right there, then this is going to cancel out. Once it reaches to its highest point, it is going to stop momentarily, and that's the height that we are interested in, so that goes away. Also, we can see that our m's cancel each other out. And now we can just solve for that h right there. And we're going to have 1/2 of 3.47 squared, and that's going to be divided by g, which is 9.8, and that's going to be our h final. And that's going to give us 0.61. Let me check these numbers. I'm looking at my answers to the previous one, and let me just double check those to see where I made that mistake. All right, so double checking those answers, it seems like I made the mistake originally on my on your review sheet. So that should be 3.47 or 0.61. If I happen to have messed up yet again, the method to calculate this is still going to be the same. All right, so I got a height of 0.61, which would be question number 24. And now the last question is how much kinetic energy is lost? So we're going to say 1/2 mv final squared minus 1/2 mv initial squared. So once we have this bullet hit this block, we're going to have 1/2. Now the mass of the bullet in the block is going to be 1.515, and the velocity is going to be 3.47 squared. Okay, so let's check that out. So 3.47 squared times 1.515 divided by 2. We're going to have 9.12 joules. Okay, and now our initial kinetic energy is going to be 1/2 0.015, because remember, initially the bullet was the only thing that was moving, so it was the only thing that had kinetic energy. So 0.015 divided by 2, and the initial velocity was 350. So we can see here that we're going to have a lot of kinetic energy. 350 squared times 0.015 divided by 2 is going to give us 918 minus 918 and 919 minus 9, and essentially that's going to give us 910 joules that is lost. And that is the answer to 25. Again, these questions will be similar on your multiple choice test. Take your time, make sure you have all your formulas ready to go, and good luck and have fun. Take care.